Hello students, welcome back to CLARIconcepts, Unleashing Conceptual Learning. Today we are going to solve various numericals examples on buoyancy. So let us continue our discussion where we left in the previous class. But before looking at this lecture, I sincerely request you and appeal you to go through my lecture on buoyancy effect and how you can exactly calculate the buoyancy force, because here we will solve the numericals. But the understanding of this formulas and all I have already taught you in the previous lecture. So please visit that and then come back over here. So let us talk about the fourth example. Find the volume of the water displaced and the position of center of buoyancy for a wooden block of width 2.5 meter and depth 1.5 meter when it floats horizontally in a water. So I have a water and a wooden block which is floating on the surface of water with a height of 1.5 meter and the width of 2.5 meter. The density of wooden block is 650 kg per meter cube and the length of the block is 6 meters. So the perpendicular length that they are saying is 6 meter, right? This is the cross sectional view, and the density of wooden block is given to you as 650 kg per meter cube. They have asked you to find out the volume of the water displaced and the position of center of buoyancy. Now see, center of buoyancy position is always at the centroid of the volume displaced. Now when you say centroid, that means centroid of the volume displaced. So let's say this is h, the depth is h. So buoyancy point will be over here and this will exactly be h by 2 meters from the bottom portion. So first h is need to be found out. So first let us find out the volume of the water displaced. So when body is floating, can I say weight of the block should be equals to the buoyancy force? Rather weight of the wooden block. So I'll just put wooden because you might get confused this with the buoyancy, right? So weight of the wooden block should be equal to the buoyancy force. Yes. What is weight of the wooden block? Mass of the wooden block into g. What is buoyancy force? Weight of the water displaced by the wooden block. What is weight of the water displaced? It is mass of the water displaced multiplied by g is the weight. Your g is cancelled. What is mass of wood? Mass of wood is density of food into volume of food. What is mass of water displaced? It is density of the fluid or water into volume of the water displaced. Yes. Now let us do the calculations. Rho W is 650. Volume of water displaced, volume of the wood is what? 2.5 into 1.5 into 6. 2.5 into 1.5 into 6, that is equals to density of the water is 1000 into volume of the water displaced, it is 2.5 into h into 6. 2.5 into h into 6. So you see 2.5 and 6 will get cancelled on both the sides. The h that you will get is 650 divided by 1000 and multiplied by 1.5. H will be 0.975 meters. So out of 1.5, the H is 0.975 and that divided by 2 will give you 0.4875. So this distance, or you can also say this is also H by 2. So this is 48. This is 4875.4875 meters. This is one of the answer. The buoyancy location is 0.4875 meters from a free surface of water, right? This you got one of the answer. Now, what is the volume of the water displaced? You have not calculated that. How do you calculate that? Once I know the H, volume of the water displaced is equals to 2.5 into H into 6. 2.5 into H into 6. This is 2.5 into what is H? H is 0.975 into 6. 2.5 into 0.975 into 6. This is 14.625 meter cube. This is volume. Answer number 2. And this is answer number 1. So I hope you got this. I mean, you are understanding how to solve numericals. Let me check the answers. 14.625 meter cube and then H is, so this is 0.487. Perfect. Very good. Let us take one more example and understand how to solve another examples on buoyancy. Find the density of a metallic body which floats at an interface of mercury of specific gravity 13.6 and water such that 40% of its volume is submerged in mercury and 60% of its volume in water. Very interesting question. See, you have a mercury and then above it you have a water, and there is a metallic body which is lying there, which is floating there at the junction, such that 40% of its volume is submerged in mercury, that means over here, and 60% in water. You are supposed to find out density of the metallic body. So let us assume that V is the volume of body, total volume, right? Now, when it is floating on this surface, can I say weight of this metallic body is equals to the buoyancy force? When you talk about weight and buoyancy force, can you say mass of this body into G should be equals to the buoyancy force? What is buoyancy force? Volume of the body, weight of the fluid displaced. Now here there are two different fluids being displaced. So you will have to add both this portion. So firstly you will talk about the water portion and then you will talk about the mercury. So what is the weight of the water displaced? I will put weight of the water displaced into G is the weight, mass of the water displaced into G plus mass of the mercury displaced into G. So you can take G common and out. Plus mass of mercury displaced into G. G will get cancelled. Now what is mass of the body itself? Can I say density of the body into volume V? Yes, is equals to, what is mass of water displaced? Can I say it is density of water into volume of water displaced? Plus what is mass of mercury displaced? Can I say this is density of mercury into volume of mercury displaced? Very easy. Now see, what is density of the body? I don't know. I'll just put it like this, density of the body. V also I don't know. V also I don't know, right? And that is equals to density of water is 1000. What is volume of the water displaced? How much volume is displaced? 60% of the total body volume. So can I say this is 0.6 into V, where V is total volume of the block? Simple. Plus what is mercury density? See, 13.6 is the specific gravity. So you multiply by 1000 to get density. So this is 13600 into what is volume of mercury displaced? 40% of total volume. So 40% is 0.4 times V. You see, you take V common and out. So simply if you calculate this, what you will get? Rho B into V is equals to, this is 600 V plus 13600 into 0.4. This is 6040 V. And V will get cancelled. So density of the body is 6040 kg per meter cube. Answer. See, you just have to stay by the fundamental concepts. Let me check the answer. Yeah, 6040 is the correct answer. So no need to worry. Whenever you see this kind of conceptual numerical, simply stay by the concepts. Whenever some body is floating, always make sure that the weight of the body is balanced by the total buoyancy force, and equate that, you will get the answers. Thank you so much. See you in the next class. For more such conceptual videos on engineering concepts and other subjects, visit our website www.clariconcepts.com. Remember, this is concepts, last there is an S. Thank you so much.